How to graph parabolas. So as we know, in quadratics there are three equations or three forms that you're going to learn about quadratics. The first one is vertex form, second one is factor form, third one is standard form. Easy, mediocre, and hard. So these differ. So first we're going to take a look at is vertex, the easiest one. So what we could tell from our vertex form is that there are a lot of graphing components that we could take this off from. So example 3, which is the k value, is determines whether our graph or our parabola will go up or down. And that all determines if it's plus or minus. Plus goes up and minus goes down. Now it's -5 here, or called the axis of symmetry, determines whether our parabola goes left or right. So, and keep in mind that an axis symmetry always has to be switched. So -5 would be turned into +5. So to go right. So it's vice versa. This is +5, this has been -5. They'll go left. So like I said, if it's minus, left. If it's positive, it's right. Alright. And then finally we have our 2 here, or our a value. Just to let you know here, this is our k, which is as well called the optimal value. And these two make up our vertex. So our vertex is -5 and 3. And this number 2 here determines our parabola, if it's going to be a compression or a stretch. And just keep in mind that. Give me a sec. Just going to show you right here quickly. Alright, so if it's anywhere greater than -1 or anywhere greater than 1, your parabola will stretch gradually. If it is lower or less than -1 or +1, then it's going to be a compression. So stretch and compression. So anywhere lower than 1 or -1, compression. Anywhere bigger than 1, -1, it's going to stretch. So like this way we're talking about.
Through x-axis.
So from the y value, it's going to stretch if it's greater than 1 or -1, and its score is going to compress by if it's lower than -1 or 1. So as you see, it's a 2 here, so it's going to stretch. So let's start with our very first point here, which is 0 and 0. As you see, this is our startup parabola. You can always graph it first, then plot it down, but that would take too much time, and this is our fastest way, and it's called a step pattern. So every time you move once on the x-intercept, you go up by 1, 3, 5 on the y-intercept. So 1, and you go up by 1, then 2, then up by 3, and then 3. You go up all the way by 5. And that's the step pattern. So you go 1, 3, 5. Odd numbers. And then what you do is, after that, what I like to do is take the y value and multiply it by 2. Or if it's a fraction, multiply it by a fraction. So let's see. So 2 multiplied by 0. So it's 2 zeros. We're going to multiply only the y value. So 2 multiplied by 0 gives you 0. But we're not finished yet because we still have the -5 and the +3. So as you see, -5 translates to +5, which means it goes to the right. So let's count right now. So 1, 2, 3, 4, 5, and it goes up by 3. 1, 2, 3. And that is our very first point, 0 and 0. So let's just plot that down. It's up to you. I'm going to plot it down so you can know where we're at. So 5 and 3. Now our second one is 1 and 1. So 2 multiplied by 1, so it's right here, this gradient. So when you multiply 1 with 2, you will get 1 and 2. So that means instead of here, it's going to go up here. Now we move up to the 5. So 1, 2, 3, 4, 5, and then up by 3. 1, 2, 3. And notice if you get this correct, the 3 goes with the 2. So as you see, it's supposed to be 2 apart because over here, this is our normal one. But then when you multiply it by 2, the y value will go up by 1. So that means it's stretching. And same thing, it's symmetrical as well. And we're going to do one more time for the final one, which is right here. So that is, so that's 2 and 4. Alright, like I said, you just have 1, 3, 5. You can just count up 2. So that's 1, 1, 2, 3, 4. and that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. So 2 and 4. Multiply 4 with 2 and you get 8. So what you do is you have to 2 and 8. Oh, my apologies. That's supposed to be a negative. And that's 2 and 4. We're going to code here actually. Why not here? Yeah, 2 and 4. So multiply that with 2, you get 8, 2 and 8. So you go up by 4. 1, 2, 3, 4. There you go. You're up by 8 now. And all you got to do is go right by 5 and up by 3. So 1, 2, 3. Oh, 4, 5. Go up by 3. 1, 2, and 3. So you go up by that much. Let me see if I'm correct. 1, 2, 3. Yep, that's correct. And as you see, it's symmetrical always, so you just put another point here, and there you go. That is your parabola. I'm not going to go any higher because it's going to go off the graph. That's here. That is your parabola. I'm going to try my best to... There you go. That is your parabola equals, and you just put your equations so whoever is checking can know what equation were you doing, were you graphing. So 5 squared plus 3. And that is how you graph a parabola. Now, what you could do in the right therefore statement, that's it. Now, this is the very easy way to graphing parabolas. But you can graph them in factor form, standard form. These are a little bit more harder and challenging, but they will have to eventually ask you in a few tests, such as Unit 2, which you're going to learn factored form, and Unit 3. Alright, so I'm going to show you that right now. So as you see, that is our answer. Not our answer, sorry. This is our parabola. And you can just write a therefore statement. That's pretty much it. Yeah. Alright, so let's start with standard form. So how to graph on standard form. Alright, so you have your equation here, which is y equals negative 2x squared plus 4x plus 3. Now, first we're going to find the axis symmetry. And this is the little form or expression that you're going to have to solve with. So x equals negative b divided by 2a. So keep in mind that, as we just spoke about it in our last, so which was how to graph parabolas with vertex form, standard form is y equals ax squared plus by plus c. So we're going to use the b, so it's right here, which is for some reason x. It shouldn't be, so by. So it's supposed to be 4y. So it's going to be 4. You're going to substitute negative 4 right here, or 4. So it's going to be negative 4. And you're going to substitute your a value, which is right here, which is negative 2. So 2 times negative 2 is negative 4. Negative 4 divided by negative 4 equals 1. And that is your first vertex, your axis of symmetry. Next, you're going to find your optimal value, which is, what you have to do is 4 times 1 divided by 2 and plus 3. So 2, you have to half it, and 4 comes from b, so you have to do b times 1, which comes from, again, from your vertex. So put your b here, b value goes here, your a value goes, not a value, you just half it, so your b value times your vertex, you half it and you add it by your c value and you get your answer. So 4 times 1 is 4, divided by 2 is 2, you add that by 3, it's 5. And that is your optimal value. And now you have your vertex. So now we have an idea of where our vertex is, or where our starting point off is. So as you see, we go 1 here, and 1, 2, 3, 4, 5. And as you see, you could tell by the negative up here is it's going to go facing down. It's opening downwards. So you could get an idea of where it's going to open up. You can just put a little line here if you want to get a nice idea of where it's going to open up, where your X-intercept is going to be. That's what we're going to find out next. So after finding your vertex, and you already found your negative where it's opening upwards or downwards, you can always tell by the a value if it's negative or positive. Again, positive opening upwards, negative means opening downwards. So to find your the X-intercepts, so you can't do the step value first, because you can't do the step value, but another easier way is using this. So you could cancel off this, the 4y plus 3, we're going to use this part of the equation, negative 2x squared. So negative 2x squared equals every step for y. So what that means is that whatever number you put here, so example 1, every one, so the next step, so our first step we're going to do, it's going to equal to that amount of steps that we're going to make up for y. So here's an example. So negative 2 times 1 squared is negative 2. Square that by 2. So let's see if I'm correct. No, I'm not. It's 2 actually. So equals negative 2. Wow, can't believe it. Anyways, so you go next. So you move one step by 1, as you see here, and it would go up by negative 2. So right here, 1, 2. So that's your first part, negative 2. Now second, and as you see, symmetrical 2. Now what's going to be your first second step? That's where you find it again. Negative 2 times 2 squared equals, let's see if I get this one correct. And it is, let me think, negative 8. Yes, I got it correct. Sweet. So the second step you make, you go up, you go down by negative 8. My apologies. So the next step, so after your second step, you're going down by negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So, and symmetrical as well too. So that is your equation or your parabola. So I'm just gonna, let me see, where was I? Oh, whoops, right here. And that is your equation, your parabola. And you just write your equation here. So 2x squared plus 4y plus 3. Now, you get the idea of, whoops, sorry about that. So as you see, you could get an idea, whoops, I think I rumbled there. So as you could get an idea of what standard form is like. You're not going to learn this at all in grade 10. You're going to learn another way by doing it through factored form. You're going to first factor it through, which you'll learn in my website, and then you're going to use factored form to find the graph or to graph it. But for now, we're going to go straight to graphing for factored form. So this is how you graph for factored form. Now, as you can see, we already have our equation, y equals negative 2, x plus 3, and then x minus 7. So what you do is, to find your zeros, which is, or it could be translated to roots, or to your intercepts, you just change these to 3, negative 3, and positive 7. So always after you get your little, after factoring it down, let's say, because usually through standard form, you're not going to do this. Standard form, you're going to do a whole another way, and you're going to keep it through factored form. So at the end, when you get your answer, you switch that answer. So instead, the zeros will be negative 3, 0, and then positive 7, and 0. You don't have to add the positive. This is your zeros, or what you call the roots, which is another word for zeros, and your intercepts. So you can plug that in right now on your graph. So negative 3, and then positive 7. Right here. So those are your two intercepts right here. So negative 3 and positive 7. So now we have to find a direction of opening. So as I said, look up here in the A value. If it's negative, opening downwards, positive upwards, opening downwards. If you want, you could give yourself a little bit of an idea. So as you see, we don't know where our vertex is yet. We're just giving ourselves a little bit of an idea of how our x-intercept, where our vertex is. So now we have found, let's see, so now we have to find out direction of opening is downward. Let's just answer that too. And now we have to find our axis of symmetry, which is simple too. You just do 7 plus negative 3 and divide that by 2. So, because that means the reason why you do divide by 2, because axis of symmetry is in the midpoint of this whole, of the parabola. So we're going to do that right now. I'm going to punch it in right now on my calculator. So 7 plus negative 3, and you divide that by 2. Let me just make sure I'm correct. So 7 plus negative 3, so you get 4, and you divide it by 2, which is 2. Yeah, so positive 2, 1, 2. Yeah, 2. So this is where your first part of the vertex is going to be. So as you see, it's 2. Now you have to find your optimal value. So let's just fill out the vertex here. So the first vertex is here is 2. And now we still have to find our y value, our optimal value. To find your optimal value, it's really simple too. You just substitute into your last form, which was -2, and you substitute x with 2 because the vertex is 2. So you substitute 2, so it would have been -2 x plus 3, and then x times x minus 7. It's going to be 2 times 2 minus 3, or plus 3, my apologies, and then 2 minus 7. Then you just do bedmass. So as you see here, -2 stays out. 2 plus 3 is 1. Oh, sorry, my apologies. 5. And then 2 minus 7 is -5. And at the end, you just want to multiply it. So if I'm correct, so your answer will be -50. Let me see if I'm correct. Yeah, so -50. And that is your answer. That is your optimal value vertex. And there you go. That's pretty much it. There is your answer. You just plug it in as your equation. 2x plus 3, and then 7, and then what was it? X minus 7. And that is your how you factor or graph using factored form. So there's your X-Intercepts. There's your oh yeah, I forgot. Let me just put it in. I'm gonna pretend this is 50. Let's just graph in our real parabola. And that is our parabola. There it is. So as you see, this is another way of factoring or graphing, is through factored form. This is what you're going to be using mostly to help you through standard form. You're going to get a lot of this throughout Unit 2, Unit 3 of quadratics. They're going to give you standard form, but you're not going to be able to use this equation yet because it's for later on grades. You're going to use factored form. You're going to factor it off first for standard form, and then you're going to, at the end, you're going to use factored form to factor it, graph it, and that's pretty much it. And yeah, that's all the 3 ways of graphing.